In this video, we will be concentrating on descriptive statistics. So what it is described as, basically descriptive statistics are descriptive coefficients that summarizes a given data set, which can be either a representation of the entire or a sample of population. Okay, so this is the same way how we kind of define with respect to uh, the statistics itself, like with the example of representing with respect to like stage or a district population. Okay, so there you can just make samples with respect to tens of populations and then merge all together. Okay, so descriptive statistics are broken down into measure of center tendency and measure of spread or variability. Okay, so we'll be seeing them one at a time. So in this video, we'll concentrate on measure of center tendency. Okay, so basically this graph can represent with respect to the measure of variable population. Okay, so basically here we have something like blue is 68% and pink is like it is included blue, so that's why it is like 95% and 99. So whatever this percentage we are getting, this will be like the measure of center tendency, so where exactly the center will lies, and the y-axis would be nothing but the measure of spread. So it will make more sense once we understand with respect to what exactly is measure of central tendency and also the measure of the spread. Okay, so we'll see about measure of central tendency in this video. So when you say the measure of central tendency, we have basically we are talking about three things. Okay, so one is mean, uh, then a median, and the mode. Okay, so we'll see with respect to examples what they are, and also with respect to basic definitions of them. Okay, so the first one is like uh, we'll see about mean. So the mean, which is referred as the average. Okay, so I hope everyone knows what exactly is taking average of a few values. Again, here when it comes to this measure of center tendency, we'll be working on with respect to only numeric data set. Okay, so basically which is referred as the average or the expected value. So it is nothing but the average value of the population or the sample. Okay, so this gives the value of approximate idea, gives us an approximate idea of what exactly is the entire data looks like. Okay, so we'll see examples to understand better. So on the right hand side we have you consider three different bins. Okay, so these bins have values, like the first one has the value 5, and the second one has the value 6, and the third one has 7. Okay, so you just take average. So basically you'll get the sum of individual ones. Okay, so everything, all the individual ones divided by the total number of samples we have. Okay, so the weightage of bins 5, 6, 7, after adding it we'll be having something like 18, divided by total number of bins what we have over here is 3. Okay, so it is like 18 by 3, so that is nothing but equal to 6. Okay, so this is the mean of any kind of data. So this is a very basic example what we are seeing over here. So just 5, 6 and 7. So if you consider a large data set which will have hundreds and thousands over there, so basically you will be adding everything and just getting the mean. Okay, to understand more mean in terms of statistical formula, so basically you can consider x as mean, summation of x. Okay, so here the Greek alphabet, the summation what we are using is usually for summation is nothing but sum of all the values. Okay, so this is how we represent summation of x, and then n. N will be equal to the number of observations. So basically the number of data sets or inputs or all the data which is available. So that is the number of observations. And with respect to the simpler formula, like mean is nothing but the summation of all the values divided by total number of total number of observations. So this is the formula. Okay, so summation of all the values divided by total number of sum. So x bar, the again mean is represented with x bar. So I forgot to mention an x bar over here. Okay, so summation of x divided by n. So that will be our mean. And next we'll see with an examples. Okay, so examples for mean. So let us consider there are three baskets, A, B, and C, having 12, 14, and 22 apples respectively in their three locations. And the farmer, you can consider anyone, Mr. Orchard wants to know how many apples are on the bags on an average, like all the bags have. Okay, so based on how many total apples it has, since it has 3 bags, so you can divide it maybe, if you wanna like distribute it properly. So the answer would be 16. Okay, so basic mathematics over here. 12 plus 14 plus 22. Okay, so then divided by 3, you will be ending up with an answer 16. So 16 is nothing but our mean of our this data set. Okay, having the apples in different baskets. Okay, so again, let us consider a similar example with the different. Okay, so there are basically 3 baskets, A, B, and C, having 12, 14, and 220 apples. Okay, respective from each, respectively from 3 different locations. So again, the farmer wants to know how many apples on an average does he have. Okay, so but here you can see the basket C has a lot of weightage. So before me explaining more, I recommend everyone to just pause the video over here and see, calculate the mean of it to understand what exactly it is. Okay, okay, I think we'll continue. I hope everyone has evaluated. The answer is 82. Okay, so basically here 82 apples is like kind of mean of it. Okay, so but you consider with respect to individual data set, whereas C has 220. Okay, so weightage is kind of increasing, whereas 12 and 14 is kind of very way across from 220 apples, right? So there is a lot of difference between the quantitative values. So hence the mean also is coming somewhere in between of 3. Okay, so but it is like, if you want to consider only these two median, it will be like 13 mean, right? So if you consider these two, it will be again going up somewhere around 90 plus. Okay, so again, the mean is not kind of the exact answer what we will do. So instead of just going with respect to a mean, we have the next level as median. Okay, so basically here, whatever the value 220 is something known as outlier. Okay, so before going to median, we'll understand what exactly is outlier. Okay, so basically here you can consider the salary of a company. So Mr. X has some kind of $1,500, and Mr. Y has $1,200, and there is a giant person over here who is like Elon Musk. So we'll consider $1 billion as his income. So if you want to calculate mean, so the mean would be something like 333, 334, 233.33. Okay, so if you're telling this is the average salary of a like persons, so if you eliminate even Elon Musk over here at that situation, the mean between Mr. X and Mr. Y would be somewhere around $1,350. Okay, so but just because we have someone who is like an outlier, the approximate or the mean drastically shifts. Okay, so again, to get the nominal value, we would this because of these outliers, we'll be facing the issue. So again, if you are working on a real life example, you will understand better. So but basically here, to overcome this, we will be having median. Okay, so median is the middle observation after the observations are arranged in ascending order. Okay, so we'll be having the observations arranged in ascending order, and then we'll be finding out the middle observation in such a way that the outliers doesn't affect much in any direction. Okay, so basically median would be something like if you're spreading with respect to a graph from LHS to RHS, sorry, from 0 to upward projectile with respect to x-axis. So arranging in ascending order would be giving you a graph something like it can be a random graph, but the outliers doesn't affect. So middle of the graph is usually what is the middle of your x-axis. Okay, so maybe with examples it will understand better. Now coming to the formula, so basically median can be calculated in 2 ways, but basically it is the number of observations we have, or a number of data set what we have. Okay, so basically if n is odd, the median would be n plus 1 divided by 2. In our previous example, we had 3 samples. So 3 is odd, 3 plus 1 divided by 2. That will be nothing but our second sample. So now the median will be the second position. Okay, so whatever the value is the median, so that will be giving. And when it comes to even number, so again we can't, if at all we have 4 samples, we will be getting any middle value. Okay, so 1, 2, 3, 4, 2 and 3 both will have almost equal weightage, so that's why we'll take average of those. Okay, so that's why median over here is written as n divided by 2th position plus n by 2 plus first position. These are the observations, then take average of them. Okay, So this is what we do when we have n as our even samples. So in that this scenario, with respect to median, we won't be having any kind of outliers having huge impact. Okay. So again, going back to the same example, if you see the example, Mr. X has 1,500 and Mr. Y has 1,200, and following Mr. Elon Musk has $1 billion. So the median would be something like $1,500. Okay, arranging them in ascending 1,200, 1,500, and billion. So then the median would be this. So the second position, which I just mentioned earlier, so that would be our median. So hence our median is $1,500. So maybe this outlier is varying much, but with respect to the other data, it is not varying much. Okay. So that is with respect to median. We'll see another example. So basically here we have four families meeting at a restaurant to have dinner together. Okay. So the manager will ask a host, whoever is hosting the dinner, for how many average number of people are attending in the family, so that he can arrange the tables accordingly. Okay. So the host recollects that family 1 has 3 members, family 2 has 4 members, family 3 has 5 members, family 4 has 5 members. Excuse me. So I want everyone to just pause the video and find out what are the mean and median of these values. We'll continue. The mean value, if you just calculate, it is 5 plus 5 plus 4 plus 3 divided by 4, so that would give something like 4.25. Okay, so you cannot have a quarter of a person, or you cannot place a quarter of a table, right? So again, let us go with the median. Okay, so median would be something like here it's the 4 values, so that's why you need to take the middle two positions. So 4 plus 1 divided by 2, 4 by 2, that is the second position. 4 plus 1 divided by 2, that is the third position. Okay, so basically here the average of this. Okay, so 4 plus 5 divided by 2, so that is 4.5. Again, similar to the example of quarter, we can't have half of a person or a half of a table, half of a chair. Okay, so the answer, like if you are considering with respect to median, they like help the host with respect to the above median data. The answer would be 4.5. Okay, so again, this does not suffice with respect to this example. So we have something known as mode for this. Okay, so again, I think everyone by this time would be thinking like mean and median are very easy to calculate, or like progressively mode would be difficult, but actually mode is the very simpler one. So mode is basically observation of highest number of occurrence. Okay, so which is the number which is occurring highest. Okay, highest in number in the data. So the data doesn't need to be rearranged. So we can just identify mode by just giving a glance over the frequency of observation. So basically here you can have a random data set. So maybe you can tell this is like 2, 1, some kind of values. And over here in this observation, your 6, the value 6 is repeating, like it has the highest number of frequencies. So hence our mode will be 6 over here with respect to this visual representation of data set. So similarly, if we go back to the same example, okay, before going back to the same example, we'll see another example. So the amount of money each person has in the pocket is like mentioned in this way. Okay, so maybe 2, 8, 10, 15, 20, 8, 5, 7, 10, 15, 21, 5, 7, 2, 5. Okay, so this is what is the amount of money is available per person in his or her pockets. So basically 2, 8, 10, 15 and 21 is occurring only one time. So uniquely it has. And 7 is occurring twice. And finally 5 is occurring 3 times. So we can directly tell 3 is our mode of this problem. Okay. So the mode, the most occurring number is 5, which occurs 3 times. So hence 3 is the mode of it. Okay. So a basic example. Now let us go back to the example where 4 families are meeting at a restaurant. Okay. So the same problem. So here what happens is the host will find out the mode as 5. Okay, so you can see 5 is repeating twice. So hence you can just put on 5 tables, and maybe the other families might have 6 also. So that's in scenarios. If you have another family as 6, family 5 as having 6 members, so maybe you have extra chairs over here which can be again swapped out very quickly. So that's why getting a mode value, like mode again helps you to find out a whole number rather than a decimal if your data set has whole numbers like this. Okay, so that is with respect to mode. So I think we'll conclude with this video, and we'll learn about more about the next. In the next part, we'll learn about descriptive statistics in the next video.